All right, maybe you've heard about how everyone's connected through 6 degrees of separation, that somebody you know knows somebody else who knows somebody else, and so on, and eventually you can be connected to pretty much everyone on the planet. Or maybe you've heard about how Kevin Bacon is within a few degrees of separation of pretty much everybody in Hollywood. Well, I used to work at imdb.com, and I can tell you that's true. Kevin Bacon is pretty well connected, but a lot of other actors are too, and Kevin Bacon's actually not the most connected actor. But I digress. Anyway, we want to bring this concept of degrees of separation to our superhero data set, where we have this sort of virtual social network of superheroes. So let's figure out the degrees of separation between any two superheroes in that data set. So is the Hulk connected to Spider-Man closely? How do you find how many connections there are between any two given superheroes that we have? Now, to find the answer, we need to introduce an algorithm called breadth first search. And it's sort of a computer sciencey network theory sort of a thing, but it's not that hard to understand. So let me walk you through how breadth first search works, and then we'll talk about how to implement it in Spark. Okay, it's time to get into some more complicated examples of using Spark. So I'm going to take some problems that you might not think of as Spark problems initially, but they can be framed as Spark problems, and they have some real world analogs too. So let's say you're working at, pick your favorite big social network company. They're going to have a lot of similar data to deal with there. And it's going to be data on the scale such that you can't do it on a single machine. So you kind of have to use Spark or something like it to analyze data and pick relationships out of some of these larger social network data sets. Anyway, what we're going to be doing is playing with superheroes in our superhero data set. And we're going to talk about an algorithm called breadth first search for finding the degrees of separation between superheroes. And along the way, we'll introduce a concept called accumulators that kind of let different executors keep track of something together. So let's talk about how we're going to go about this. So remember, what we're trying to do is figure out degrees of separation between superheroes. So we want to basically, pick someone and call them like the Kevin Bacon of superheroes or something. Let's say we want to find out how far apart Iron Man is to Spider-Man. And these lines all indicate these heroes all appeared together in the same comic books. So in this example, Spider-Man is connected to the Hulk, who is connected to Iron Man. Therefore, Spider-Man and Iron Man are 2 degrees of separation from each other, whereas the Hulk and Thor are 1 degree. The Hulk and Iron Man are 1 degree, and Thor to Spider-Man is 2 degrees. Make sense? So that's what we mean by degrees of separation. How many hops do you need to go through some common acquaintance in order to find a connection with somebody else? And to do that, we're going to use an algorithm called breadth first search. And it's kind of a computer sciencey network theory sort of thing, but it's not that hard of a concept to grasp, so let's go through it. You are going to have to understand how breadth first search works in order to understand how we're implementing it in Spark to solve this problem. And it's basically a way to search through a graph like this and figure out what are the distances between any given 2 nodes within that graph. So we're going to pick someone to start with, like the Hulk, and search our way through the whole graph, keeping track of the distances, the minimum distances, from the Hulk to any other character. So here's how breadth first search works. It's such a hard thing to say. Let's imagine that every one of these circles represents one of the superheroes in our social graph, okay? And the lines represent the connections between them. So the line means that 2 superheroes appeared together in the same comic book at some point, all right? And you can see you can have these kind of complicated relationships that go on. So it's not really a straightforward problem. We need an algorithm to solve it. Now, the idea is that we've associated each superhero with one of these circles. And not only is there a superhero ID associated with each one of these nodes, but there's also a distance to the node that we're interested in, as well as a color that we'll use to keep track of its processing state. So let's say that node S represents the Hulk, and we want to measure how many degrees of separation people are from the Hulk. Okay, so we're going to start with node S here in our example. And initially, we're going to color all of the nodes white, meaning that they are completely unprocessed. And we're going to have an initial distance of infinity, meaning that we just don't know yet. It's infinitely far away. We haven't computed it yet. Now, for our initial conditions, we know that we want to start with the Hulk, who's in this node. And we're going to change the color of that node to gray. And gray means that a node needs to be expanded upon. We've just come across it, and we need to work our way out from there. And the number 0 represents the degrees of separation from the Hulk. Because the Hulk is the Hulk, he has 0 degrees of separation to the Hulk. Okay, so our initial condition, everybody's white and infinitely far away. And we're going to start off with the person we're interested in measuring the distance from, color them gray, and give them an initial degrees of separation of 0. Now things get interesting. This is an iterative algorithm, so we're going to pass through the graph multiple times until we're finally done discovering every node in it. So in our next pass through the graph, we will take our gray node, which was the Hulk. We're going to color it black, meaning that we have processed it completely. We don't have to look at it again. But then we're going to go out to all of its connections and color those connections gray, meaning they need to be expanded upon next. And we are going to increment the distance from the original node by 1. So 0 plus 1 is 1. So we now know that nodes R and W, whoever they happen to represent, are 1 degree of separation from the Hulk, node S. Then we pass through it all again, and we have to then expand this guy in the next pass. So we'll start with him. Color that black, meaning we've processed it. Color its connections gray, meaning they need to be explored next, and increment the distance one more time. So now we know that these two nodes are 2 degrees of separation from the Hulk. And we still have to do this guy over here. Color him black. Again, increment the distance to 2 and color this new node that we just discovered gray, meaning that we need to explore it further as well. So this is the end of our second pass through the graph. Let's start our third pass. We'll start with this guy, color it black, meaning we've explored it. This guy we've already come across before, so we're going to leave him untouched and leave the previous minimum value there. But this connection is new. We're going to color that gray and increment its distance to 3. So now we're at a connection that has 3 degrees of separation from the Hulk. And then we'll explore this guy again, which will cause us to discover this node over here, who is also 3 degrees of separation. Color the original black. These ones are gray. So see what happened there? And we still have to process this guy who isn't connected to anybody, so all we have to do is mark him black, meaning we're done with him. Just have these last two to go through, and obviously they're not connected to anybody new, so nothing's really going to happen other than coloring them black to indicate that they have been visited and processed. And finally, we are done. So that is breadth first search. If that didn't make sense, it might be beneficial to go back and watch that little animation again of how the traversals work and how we actually arrived at the degrees of separation from node S as we worked our way through the graph. So next, let's talk about how we actually turn this into a Spark problem that we can run iteratively. And it's kind of interesting, so stay tuned. Okay, that's the basic concept of how breadth first search works from a conceptual standpoint, from an algorithmic standpoint. Now let's figure out how to actually apply that in Spark and in Python and actually get the results that we want to figuring out the degrees of separation between superheroes.